Here we're going to take a look at example number 2 and start to get an idea of how we can use that f.dr definition for work. So here's the idea. I want to find the work done by this vector field on a particle which moves along the curve C, which is given by this vector function. Oh, wait, that's actually a very familiar vector function. I could actually see here that this vector function is actually a circle, but it looks like it's only maybe the top half of a circle because it only goes from 0 to pi for that input value. So this is kind of the curve that I'm working with, and I progress along it in this direction. Okay, so imagine that again, I have forces that are acting upon the particle as it moves across here, and I want to know how much work this vector field does on that particle. So I know the following. I know that I can calculate work now by doing this F dotted with my dr. And the cool part is that's super easy to go ahead and actually crunch. Notice that here I can say that my F is simply just my x, y vector. My dr I can imagine as my dx, dy vector. And when I do the dot product between these two, I'm going to end up with an integral of x dx plus y dy. And I automatically can easily convert that because I already have the parameterization of the curve. So notice, I know my curve goes from 0 to pi. I know that x can be replaced with the cosine of t. Its derivative would be dx. So the derivative here is going to be a negative sine of t. And of course, I have dt. I can go ahead and replace y with the sine of t. And then dy would be cosine of t dt. I can even factor out now that common dt value and think about all the stuff that I'm going to have left on the inside. If I factor that dt value out, I see a regular old integral appearing. Ooh, which is very weird actually, because isn't this just the integral then of 0? And the integral of 0 is 0. Very surprisingly here, I do get a value of 0. And as I state down here, you can draw a picture of the particle's path and this vector field to see why this might actually be the case. This is kind of strange and maybe surprising at first. One of the things, though, that I could actually see is that if I was to go and, oops, forgot to pull this up ahead of time. If I was to go ahead and actually take a look at the 3D grapher here, I can see that I can type out my space curve. Here it is. I'll restrict it to 2D. So there's the curve that the particle is moving along. It's going to go from 0 to pi. And then I could also put in my vector field. My vector field had the formulas x, y. And you'll notice something. The vector field, is it really going to be helping? Imagining that I have a particle on here. Is it really helping at any point to push the particle along the curve? And I might be able to see very clearly, no, because it looks like each of these vectors is perfectly perpendicular to the curve at all points, which means, of course, it can't help push the curve in the direction, or push the particle in the direction of the curve. So here, this vector field does nothing to help the particle move along. So again, what we're always trying to think about is something kind of like if I'm moving around and this represents like a wind current, maybe this vector field is like the wind current. Is the wind in any way helping push me, maybe slow me down or speed me up in my motion along this path? And it seems like, well, definitely not. It's not helping me push me along the path. Maybe if it was angled slightly, right? Maybe if I had vectors that were pushing me in this direction, then possibly, right? If there were like vectors in here that moved like this, then maybe I could say that I'm going to get some work from this vector field. But here, I don't seem to get that. The very last thing we can say in this section is that I didn't have to solve the problem with this f.dr approach. I could still use this approach as well that we did in the last example. Now, it doesn't necessarily matter which approach I use because they're both identical. but you'll see very often that I will use F.dr approach in a lot of the content that we'll continue to get to. I would encourage you to try both approaches. Make sure that you're comfortable with both these ideas, so no matter which one we attempt to use, you're familiar with the concept. All right, I'll see you all then in the next section when we begin to talk about 5.3.